Parallel and perpendicular lines today. We're doing the first part of the notes on Tuesday. I will not be here, so you're going to do the homework. You will not have homework today, but you will have homework tomorrow. We'll do the second half of 4.3 on Thursday. So the essential question is, how can you recognize that lines are parallel or perpendicular? This has to do with slope, and we'll look at slope and how to determine whether or not the lines are parallel, meaning they have the same slope, or perpendicular, they have opposite reciprocal slopes. We'll go over that in more detail here in a minute. So the very first thing it talks about is parallel lines and their slopes. Two lines in the same plane that never intersect are parallel lines. That's only true for the type of geometry that we study in high school. Actually, there are lots of geometries. There's hyperbolic geometry, there's taxicab geometry, there's a bunch of geometries that we don't study and I didn't know about until college. Two distinct non-vertical lines are parallel if and only if they have the same slope. And that's the most important thing. Okay? So part of your task for this section and this chapter is to identify when you're dealing with parallel lines. And the only way to figure that out is if you find the slope for two lines that you're given or 2 points that you're given. So let's say you're given 2 points for one, 2 points for another. Find the slope between those 2 points for one and the 2 points for the other. And if they're the same slope, then they're parallel. Do you have any questions about that? All right. All right, so your approach to this one, it says determine which lines are parallel. Well, looking at it visually, they all look parallel, but you cannot go off of what it looks like. You have to actually calculate the slope. You can do it one of two ways. One way is to just say how many up and over, right? Like we've been doing. So go from point to point, up and over, up and over, up and over, and you'll see that one of them doesn't have a slope like the rest. The other thing to do is to actually use y2 minus y1 over x2 minus x1, which is the formula for your slope. And that's what we're going to do. Okay? So let's just do that so we can practice with the formula a bit more. So for A, I'm going to do y2 minus y1. So 3 minus 2 over what?
4.
Yeah, negative 4 minus 1. Perfect. 3 minus 2 is 1. Negative 4 minus 1 is?
Negative 5.
Negative 5. Okay, so negative 5. And then let's do for B. I should have just used the same colors here. Use red. Okay, then we're going to do the same thing. Let's just do 0 minus negative 1 over what? Negative 3 minus 1. So add those two. You get 1 on top. And you get what on the bottom?
Negative 4.
Are those two the same?
No.
No. So are the red and blue lines parallel?
No.
No. So this is how we can say in shorthand, A is not parallel to B. This little bar means parallel.
So it's just like a equal sign but turned.
Yeah, like an equal sign but turn this way. So A is not parallel to B. Let's see if B is parallel to C or A is parallel to C. So we still have to find the green slope. So I'm going to do negative 4 minus negative 5 over what?
Negative 3 minus 2.
Negative 3 minus 2. So negative 3 minus 2. Negative 3 minus 2. So when we calculate that, we get 1 on top over negative 5 on bottom. So C is parallel to which one? A, right. So A is not parallel to B, but A is parallel to C. Does that make sense? Do you have any questions? Okay. Okay, so it says write an equation of a line that passes through 5, negative 4, and is parallel to the line y equals 2x plus 3. So, So, in order for the lines to be parallel, you have to have the same slope. So what does our slope have to be according to that information? So we have y equals 2x plus 3. We want to find an equation that is parallel to that line. What's the slope of that equation? 2. The slope of that equation is 2. So the slope of a line parallel also has to have a slope of what? 2. So I'm going to say m sub 1 equals 2. That being the new, the slope for the new equation. So I have to come up with that new equation. Here's how I do it. Just like last time, and this was the hard stuff that most people didn't know how to do. So I'm going to go over it again. You want it to pass through the point 5, negative 4. So we're going to use y equals mx plus b, slope-intercept form. What do you think I will replace the y with?
3.
2.
No. Negative 4, with the point that you want it to pass through. Replace y with the point that you want it to pass through. So negative 4. M is going to be what? 2. Right, you want it to be parallel. X is going to be 5. Okay? And then we're solving for the value of b. So, negative 4 equals 10 plus b. Then you subtract 10 from both sides, so what's the value of b? Nope. Negative 14.
Yes, Miss Win.
So negative 14.
No way. He just was resting.
Oh, you shouldn't be resting now.
He has a headache.
Alright, so, what's the equation of my line? Y equals what? 2x minus 14. Alright, y equals 2x minus 14. That's the equation of your line. That is parallel to 2x plus 3. And it passes through the point 5, negative 4. Number 1 says line A passes through negative 5, 3, and negative 6, negative 1. Line B passes through 3, negative 2, and 2, negative 7. Are the lines parallel? Explain. A lot of you are trying to do the y equals mx plus b thing. Only do that when it's asking for write an equation, like number 2. Number 1 is just asking you to find the slope. So I'm going to find the slope between the first 2 points. So how will I do that?
Y2 minus Y1.
Y2 minus Y1 is over
Yeah, so with those points, what would that look like?
negative 1 minus 3
Uh-huh.
over negative 6 minus negative 5.
Yeah. So for the first slope, you have negative 4 on top. And then, so when you add the opposite there, what do you have on the bottom? Well, we have negative 6.
Negative.
Oh, sorry, negative 6 minus negative 5, right? On the bottom. Messed that up here.
Negative 4.
Yeah, so negative 6. Negative 6 minus negative 5 would be negative 1. So that's just 4, right? Did you all get that? Alright, so for the next one, here, we're going to do the same thing with those next 2 points. Negative 2 minus negative 7 divided by 3 minus 2. Add. We have 5 over 1. Are those parallel?
No.
Why?
Because the numerator is not the same.
Yeah, the numerator's not the same. The lines are, the slopes are not the same. Yeah. Great. Okay, the number 2 is the more difficult one. So, do you remember how we set up number 2? Any idea?
You make Y negative. Y equals MX plus
Y equals mx plus b. Perfect. So you want to start there. Y equals mx plus b. Alright, that's good so far. Now, what do I replace with y? Okay, what do I replace with m? What do I replace with m?
1/4. Negative 4.
1/4. 1/4. Why 1/4?
Because it's a slope.
It's the slope of a line parallel, right? What do I replace x with?
Negative 4.
Negative 4. And then I solve for b. Right, Armando? Okay. So, 2 equals, what's 1/4 times negative 4?
Negative 4.
No, negative 1 plus b. What's b?
B is 3.
Right. So what's the equation of my line?
Y equals 1/4 x plus.
1/4 x, y equals 1/4 x plus 3. Okay. I know what people are going to say. Well, if I'm trying to find something parallel, shouldn't it just be y equals 1/4 x plus 1? No, that's literally what I want it to be parallel to, but it can't be the exact same line. So you're trying to find the b value that's going to make it different. They're still going to be parallel, but they're not going to be the exact same line.
Where does the negative 4 go?
The negative 4, so if you take negative 4 times 1/4, you have negative 4 over 4, which is negative 1. So you're just multiplying across. Okay, let me see what the next slide is. We may or may not go over it. Oh, we get out at 1:48, don't we? So we're good. 10 minutes, plenty of time.